Right, volume and capacity of composite solids. Alright, so to start with, how do we treat complicated shapes like this? The first question we need to ask ourselves is what are the simple shapes that make up our composite solids? So here we've got a cube with a cylinder sitting on top, and note that the cylinder goes from one edge of the cube to the other edge. Not always, but in this case that's what's happening. Here we've got a rectangular prism with a triangular prism sitting on top. Now to work out the volume of the complicated solid, all we do is split it into its simple parts. So here we've got a cube, do the volume of the cube plus the volume of the cylinder, add it together. Same here, volume of the rectangular prism plus the volume of the triangular prism that sits on top. Okay, is there enough information to work out your calculations? That means do you have all the right side lengths or the relevant diameters and radii that you need to do your calculations? Okay, in this case we do. 4 meters across the cube. The diameter of the cylinder is all the way across the cube, so it's 4, and the height has got the double dashes, so it's the same measurement. Over here though, it's a little bit different. We've got the height, we've got the length, we've got the width of the rectangular prism, so we're good there. We can calculate the height of the triangle, 10 minus 5. We know the width of the triangle, or the base width, but we don't know this length up here if we were to need it for surface area. So we would need to use Pythagoras' theorem to work that out, which we'll talk about another time. Okay, pause the video, copy your notes into your book. Whenever you see this sign, pause the video, and that's when it's note-taking time. Alright, so the key idea there is that composite or complicated shapes are made up of more than one basic shape. To work out in today's lesson the volume, all we need to do is work out the volumes of each part and add them together. If it's a capacity type question, remember your conversions. 1 litre is 1000 millilitres, which is also 1000 cubic centimetres, and that means that 1 cubic centimetre equals 1 millilitre. 1 cubic metre is a kilolitre, or 1000 litres. Okay, so here's an example. We need to calculate the volume of this shape. You can see that we've got a cube plus a cylinder. So to work out the total volume, cube plus cylinder. Sketch out both shapes, that's the easiest way. Put the measurements on that you're given and work out any measurements that you need. So for the cube, straight up we're told that it's 2 centimetres by 2 centimetres by 2 centimetres because we've got the equal side length markings. For the cylinder though, we're not told how high it is. We need to infer that by the fact that the cylinder goes from edge to edge on the cube. So that means the diameter up there for the cylinder is 2 centimetres. So that means we've got a 2 centimetre diameter, which means that we've got a 1 centimetre radius. Perpendicular height for the cylinder is 3 centimetres. So then we start doing our calculations. Both of them are prisms or prism type shapes. Volume is cross-sectional area times the height. For the cylinder, the cross-section's a circle, so pi r squared times height. For the cube, work out the area of the cross-section, 2 times 2, and then multiply it by the other 2, and we get 8 cubic centimetres. For the cylinder, substitute your radius and your height, pi times 1 squared times 3, do your calculations, round it off, and you get 9.4 centimetres cubed. Then to get the final volume, we add our two answers together. 8 plus 9.4 will give us 17.4 cubic centimetres. Okay, so key points from today. Identify the different solids involved. Make sure you've got the appropriate dimensions. Calculate each individual volume and add them together to find the total. Thanks very much for watching.